Hey guys, welcome back to Algos Explain. I cut up the pattern video into two videos just because it was taking a long time just going over that first one. So I'm going to go over the P2 the same way I did the P1. We're going to go over just looking at the pattern, trying to discover the patterns, and then we're going to go over the algorithm, how I solved it, and how it works for our purposes. And so P2 here, this was P1. If you want to look at that, go ahead and look at that previous video. P2 here is slightly different, whereas this one, the numbers were just increasing. So 1, 2, 3, 4, 5, 6, just increasing numbers. This one is a little different, where it has more of a pattern that you can just look at. It's more symmetrical. 1, 2, 3, 2, 4, 3, 5, 4, 3, and you see it. So let's go ahead and look at kind of what kind of patterns that we can find out to use to help us make our algorithm. Especially with these pattern printing questions, you definitely want to, one, be able to recognize every pattern that you can, and also be able to get that next line. That way you know, okay, I really do understand the pattern, and therefore I can write an algorithm for it. And so I like to do this at first, kind of see, okay, since we're going to be printing the pattern, they want lines. So this is going to be the first line we print, second line, third line, fourth line, fifth line. And what we can see here is that something that does stand out already is the first number of each one corresponds to the line it is. So if it's my first line that I'm printing, there was a 1 that started it. If it was the second line I was printing, there's a 2, and also ends here. And so, and the 5, let's see, that's 5. It would have started with a 5, 6, 7, 8, and 8 was probably the last one. 7, 6, 5. Okay, so a little, I didn't span that out as well as I should have. Let's see, do it again. 6, 6, 7, 8, 7, 6, 5. Wait, did I mess up somewhere? 5, 6, 7, 8, 7, 6, 5. No, I think that's right. So if you did that with me, pretty much let's think about how I did that. It was just incrementing, and then at some point we decided to decrement. And so we can already see here, if we kind of break it down like this, we have a middle line, and then now this left side is identical to this right side, just mirrored. And so the first line doesn't have a mirror, but here we have a 2, 3, 4, 4, 5, 6, 5, 6, 7. And same thing here, 2, 4, 3, 6, 5, 4, 7, 6, 5, but mirrored, of course. And so that gives us a big clue into how we can write our algorithm. We know that at some point we need to flip it. And so either we flip it or we build it in reverse. That's two strategies that you can take. Both of them do work. The one that I'm thinking is going to be better, or not better, but the one that I think is more simpler is building it backwards, just because we're going to have to build it one way anyways. And what you can do is kind of, if you get my drift, we're going to build a string, right? We're going to build a string, and then I could stop at some point and then take that front side and then reverse it, and then just slap it on together and then print that. However, since I'm building the string here, especially with strings, just because you can add numbers to the front or the back, we can just as easily build it backwards as we're building that front side. And so we could have a front side and a back side string. And now the important part would be, how do I know when I start flipping? When do I start flipping? One thing that we do understand is that, let's see, first one, it has a length of 1. Let's look at the lengths again. Length 1, L, 3, L, 1, 2, 3, 4, 5, L, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Huh? Okay, I messed up somewhere for sure. 6, 7, because that doesn't look right. 6, 7, 8, 5, 6, 7, 8. Okay, I probably should have had a 9 there. I mean, so great, we made a mistake in building our last line. one indicator was that the lengths were the same. That has never happened before. Another thing that I did want to mention is when that midpoint happens, and that midpoint happens at the one, maybe not accordance to the length, but accordance to the index. And so the midpoint happened at the first, the midpoint happened at the second, the midpoint happened at the third, the midpoint happened at the fourth. And by midpoint, I mean when we should stop moving forward and start walking backwards. This one, the midpoint happened at the fourth, and so that's bad. We want the midpoint to have happened at the fifth. And so we know that we're going to start with a 5. However, 5, 6, 7, 8, 9. That way the midpoint happens at the fifth number. And then we're just going to flip it. 7, 6, 5. So 4 numbers here, 4 numbers there. Okay, we keep our mirroring, and let's fix the length. 4, 4, 1, so that's going to be 9. We can see that this is incrementing by 2 also. However, I don't know if that's going to be as useful as knowing when we're going to start flipping, just because in our algorithm we already know that we're going to build the front string, and we're going to build the front string just by incrementing the numbers starting from the index, or starting from which line we're printing. And so we're starting at the fifth line. This is our fifth time printing it. 5, 6, 7, 8, 9. Knowing we got to our fifth number, then we start going backwards. Or if we were building our string backwards from here, all we have to do is we have to just add it. If we were building a backwards string as we were building our forward string, we can just add it on. If not, we could just reverse kind of the string that we built here. Okay, cool. So that's the strategy behind this. Let's go ahead and look at the algorithm and kind of walk through that. Hey guys, welcome back. And so now this is our algorithm that we have for our pattern 2. Let's go ahead and walk through kind of what's happening, just reading the line of code, and then walk through an example going through this code. And so what we have first here is num. That's going to be kind of what they want. If n was 4, this is what they want. That's our argument. What we have here, structurally, we have 2 for loops, like the P1. And if any of this seems messy to you, if you want to go ahead and try to refactor it, maybe take some of this code out, I could totally see this middle part being yanked out and used as a helper function. In terms of this formula, it didn't look too complicated, so I opted to not pull it out. Structurally, we have 2 for loops. This bigger for loop, the outer for loop, is going to be the one that's printing the lines. And so num being the numbers of lines that we want to print, that will, maybe a better argument variable would be lines. If we want to print out 4 lines, the outer loop is what's in charge of printing it out 4 times. We can see very high level here. I is 1, I is less than or equal to num. So we know that the outer loop will run 4 times. And we can see here that the console log of the strings are part of the outer loop, not the inner loop. And so that will happen 4 times. And so, of course, the middle one will be in charge of building the string that we do print out. We have a couple of variables here: front string, back string, and current number. I went with the front string and back string method instead of taking one front string and then reversing it later. I felt just creating a back string as we're building the front string was just as good. So for the inner for loop, we use a j for a variable, and it's going to go I amount of times. And remember how we decided in our function here that the midpoint of kind of when we could stop building the formula, the midpoint of when we could stop incrementing our numbers and start decrementing it. In our case, we were building the backstring the whole time, but the moment we could pretty much stop building was that I time. So if we were on that second line, once we did that twice, once we incremented it and got to that second one, we can stop. Once we got to the third one, not incrementing it 3 times, but once we got to the third one, we can stop. Once we got to the fourth one, for line 4, we can stop. And so that is why, that's what this is going to do. That's why it's equal to I being whichever line we're on. So if we're on the first line, inner for loop is only going to do it once. Of course, it increments here, and we build our strings here. Front string is just going to do a plus equal, a space for cleanliness, and the current number. And we have our back string here, and this is going to make more sense in a little bit, but building our back string, what we do, we can't do the plus equals just because we need to do it backwards. Plus equals will always be front string. Plus equals pretty much means front string equals front string plus that. Since we want to do it backwards, we had to do it equal to current num and back string. We had to put that in the back. If we did a plus equals, it would be the back string plus the current num, which would be just like the front string. Not useful. And so once we're done with this back string, we increment the current num, and if we want to do more loops, we do more loops. If not, we come out and print the numbers here. And so let's go ahead and plug in some numbers, see what it gives us, and if there are any errors in the code, we'll find it. So let's go ahead and let's do a n equals 3 for simplicity's sake. Num equals 3. And what we'll do here, we'll keep track of front string. It's taking up a lot of space. N equals 3, fs equals something empty right now, backstring, likewise, current num is equal to the I. We haven't gotten there yet. Let's also keep track of I and j, and that's going to be pretty much it, all we have to do. And let's console log down here. And so num, that's our argument, 3, so we're going to have 3 different lines of code, or not code one, of console logs. We know that we're going to do 3 of them, and hopefully those 3 look like what we have right over here. And so front string, or let's go ahead and read through this. I is equal to 1, so let's start that off. As long as I is less than or equal to 3, yes, that works. Front string is that, back string is that, current number, that's also a 1. And so let's go into our inner for loop. J is 1, and as long as j is less than or equal to I, it is equal. So we'll start building our front string. Front string equals a space plus the current num. So we have a space plus the current num there, and if j does not equal to 1, it does equal, so let's forget that if statement. Current num goes to 2, and we go back to the for loop. Now j increments, so that's a 2. 2 less than or equal to 1. That doesn't work, so we break out of the little loop, the little for loop, console log what we have here, which is front string plus space plus back string. And so that first line of, and this was when I, just so we could visualize it better, when I was 1, we haven't incremented I yet. Front string, which is 1, plus spaces, and the back string, which is just more spaces. And if you want to prune it, you can always prune it later, or prune it pretty much right down over here before you print it out. But now since we're done with that, we go up here, increment the I is 2, and 2 less than or equal to 3, that works. And so front string, that goes back to being just an empty string. Current number is equal to I, so current I is 2, it'll get reassigned, but it's 2 anyway, so that's what it'll stay at. We'll go into a little one, j goes back to being a 1, and now 1 is less than or equal to I, yes, 1 is less than or equal to 2. So let's go ahead and build our front string, which is going to be a space plus equals the current num, which is a 2. And now I does not equal to j. That is very true. So back string, we have current num plus equals back string. And so that's just a 2 also. And we'll see how the back string gets built starting from pretty much this case right here. Current num gets incremented to a 3, and now j gets incremented to a 2, and front string, so yeah, or pretty much j is now incremented. We go to the loop again, 2 less than or equal to 2, that works. Front string, we add that current num, so we add a space and a current num, so pretty much like that. J does not equal to an I. Those are equal, and so our back string stays the same, but let's imagine, what if we had what if we didn't have this case and we just went ahead and fixed that? Our backstring is this right now. We would have done current num plus space plus backstring. So what we would have done is we would have added current string to the front of here. And you can see how we're creating it backwards. So let's pretend this is our case where we didn't have the if. So let's hold that in our back pocket. That'll help us understand this better. Our current num, we're going to increment it to a 4. And now we go back up here. J, we increment it to a 3. 3 less than or equal to 2. That doesn't work. And so we console log here front string plus space plus back string. And so that's going to be, let's see. And the back string never had a real space in front of it. It was just 2. For starters, or did it have a space? Current num, I forget. We'll pay closer attention next time. But however, front string plus back string, that's 2, 3, and 2. 2, 3, and 2. And now imagine if we hadn't had that if statement here, it would have been in an alternate universe 2, 3 as our front string plus 3, 2. And that's not what we want. We don't want that extra 3 there. And that extra 3 happens when the I is equal to the J. And so let's continue on. Let's leave that here. Erase that. And we just printed that out, so we have to increment the I to a 3. Now we check, okay, 3 less than or equal to a 3 here. That's good. This is going to be our last time because next time we increment it, we're done. But we know we only need to print out one more. So we're good. We're reaching our end. Front string is going to be front string and back string both reinitialized. Current num goes to being equal to I, which is 3. And now J is 1 again, so 1. And let's see. J, okay, so the condition 1 less than or equal to I less than or equal to 3, that works. Let's go in here and start creating our front string, current num, which is a 3. And now does J equal to I? Nope. So we'll create our backstring 2, which is current num plus, so current num, oh yeah, the current num had no space as a part of it, so that would have been a clean number without a space in front, plus all these things in the back here. We added a space here, so it probably looks something like that. Let's go ahead. So we did that if statement. We increment the current num to a 4. And we're at the end of this inner for loop. We increment the J to a 2. The J2 less than or equal to 3, that works. So let's continue building. Our front string is plus equals. So this front string, what we have, plus equals to our 4. So we add that. Does I equal to J? 3 and 2, nope. So let's continue building our backstring. So now backstring equals current num. So, I mean, I'm hoping we all understand the concept of this, but remember backstring was just a 3, and so we add current num, which is a 4, plus a space, plus whatever our backstring was, which was just a 3. So it looks something like that, and it did have a space behind it because the first time we added a space, and we did that. Current num, we increment that to a 5, and we increment the J now, so that's a 3. J, 3 less than or equal to 3, that works. Let's do it one more time here. Front string plus equal to current number. We add that in the back there. And this time I equals to J. So we're not going to touch our backstring, but again, just for repetition's sake, let's assume in an alternate universe we didn't have this condition. And so what we're going to do is current num 5 plus a space plus, so pretty much plus whatever this was. So now it's going to be the 4 and the 3, like that. And current num increments to a 6. That doesn't really matter because J increments here to a 4, and at this point 4 is not less than or equal to the I, so we come out console log this one, front string plus space plus back string. So that's our front string, that's our back string. Let's add that. 3, 4, 5, 4, 3. That looks good. If we didn't, what would we have done? 3, 4, 5. that would have been our backstring 5, 4, 3. Without a space there too, by the way, it would have looked extra ugly. 5, 4, 3. It would have looked like that. But of course, we already solved for it by adding that condition there. And that condition there, I wasn't able to, when I was first thinking about the algorithm, I didn't just simply know it off the first hand. When I did first create this algorithm, I didn't have that condition in there. I just had this. And so I was printing out cases that looked like this. And I realized, hey, this looks really weird. What's going on? I know that the middle number, is being duplicated. And I was thinking, okay, how do I get rid of that middle number? At first, I actually was doing all sorts of other cases where I tested it out and it looked like I was getting rid of the last number, getting rid of some other numbers. But eventually I realized, okay, at what point do we build that 5 or that middle number in there? It is the last case. And so that last case would have been the last case in this for loop, which would be if j is equal to the I. And so as long as the j doesn't equal to the I, we'll continue building our backstring. We could have also said just continue or something along those lines. But we do have what we want here. We're almost finished. We just finished printing that out. We increment the I to a 4. I is not less than or equal to 3, and so we do. And now we're finished. We're done with this. We were able to print it out. And so when you run this function, your triangle is going to look like this pretty much. Right triangle. It's not going to look pretty like this, but for the most part, this is what they're looking for. Okay, that was a pretty big run through. I didn't know N3. I thought that was going to be short, but it was a little longer than I expected. Hopefully that helped you out. If it did, be sure to like, comment, and subscribe, and email me at algosexplained@gmail.com. Sorry if I can't get to your problem, but if I can, then hopefully you're watching. Thanks. Bye.